Okay. In this illustration, we have to find out the position of the central maxima. The condition given is there's a vessel ABCD of 10 centimeter width. This is the vessel ABCD. The width is 10 centimeter. There's a point source, monochromatic source at a distance of 2 meter from the vessel, which illuminates two small slits S1 and S2, which are sealed with the identical glass plates of equal thickness. The distance between the slits is given to us as zero point 0.8 millimeter, and this is a line POQ. This is a line which is perpendicular to the planes AB and CD. O being the midpoint of S1 and S2, and Q is the point on this plane CD. Right now, it is given to us that there's a point source. This we have to calculate the position of the bright fringe that is found. So calculate the position of the central bright fringe on the other wall CD with respect to the line OQ. So we have to find out where will this central maxima be formed on this point. I've assumed that this is the point where the central maxima will be formed, which is at a distance of y2 from the point Q. Now, as this is the source of the light, the rays of light the waves will come like this. These are the slits S1 and S2. Now, after they pass through S1 and S2, they meet at this point C. So, if C is the central maxima, then delta x, that is the path difference, total path difference at this point C should be equal to 0. Now, there are two types of path differences that are going to take place here. That is, before the light reaches the slits S1 and S2, there is going to be some path difference which we can calculate. If this distance is this is the distance between S1 and S2, this distance is given as small d, and if this angle is alpha, then I can write tan alpha tan alpha will be equal to y1 upon this distance, y1 upon d1. Now y1 is given to us as 40 centimeter, so this will be 40 into 10 to the power minus 2 upon d1 is given to us as 2 meters, so this will be 1 by 5. Now if we want to calculate what is sine alpha will be equal to 1 by root over 26, which is approximately equal to 1 by 5.1. I can say this is nothing but approximately equal to 1 by 5, that is tan alpha. So if tan alpha is equal to sine alpha, now this will be the path difference. This, if we drop a perpendicular from this point till here, so this is going to be the path difference, which will be nothing but d sine alpha. So let's say the initial path difference, that is delta x1, that will be equal to d sine alpha, which is nothing but equal to d is given to us as 0.8 into 10 to the power minus 3.8 mm into sine alpha will be 1 by 5, which is 0.16 mm. So delta x1, that is before the light reaches S1 and S2, the path difference, that is delta x1, which is 0.16 mm. Now after the light passes from S1 and S2 to reach this point of central maxima, there is one more path difference. If let's say this angle is theta, then we will say the path difference will be, if we drop this perpendicular, then it will be this, that is d sine theta. So delta x2 will be equal to d sine theta. Now again, tan theta can be said to be y2 by d2, which is y2 is this position and d2 is this. Now we need to find out what y2 is. So if we get to find out what tan theta is, then we can probably find out what y2 is, and we'll thus find the position of central maximum. So delta x2, that is the path difference after it is after it has passed through S1 and S2, delta x2 will be nothing but d sine theta. Now delta x2 is d sine theta, so we can say the net path difference delta x, that will be equal to delta x1 plus or minus delta x2. Now this is the path difference that is traveled, the extra path that is traveled by this light over this one. So this has traveled more as compared to this light. And in the second case, this is the distance, that is this light traveled more as compared to this light. So we'll write this as mod of delta x1 minus delta x2. Now central maxima, for central maxima, delta x should be equal to 0. This implies that delta x1 is equal to delta x2. Now, so delta x1 is 0.16 into 10 to the power minus 3, that is equal to d sine theta. So sine theta comes out to be 0.16 into 10 to the power minus 3 upon d, which is 0.8 into 10 to the power minus 3, which comes out to be 1 by 5. So sine theta is 1 by 5. So tan theta will be equal to 1 by root over 24, which is approximately equal to 1 by 4.9 or 1 by 5. So tan theta, from here we can say tan theta is y2 upon d2, which is nothing but 1 by 5, implies y2 will be equal to d2 by 5, and d2 is this distance, that is the width, so that will become out to be 2 centimeters. That is the answer. Now, there's second part to this question, that if the vessel is now filled with a liquid up to OQ, that is, it is filled up to this point with the liquid, the central bright fringe is found at Q. The central bright fringe is shifted from this point to this point. Then we have to calculate the refractive index of the liquid. If you want to calculate the refractive index of the liquid, let's analyze the situation in the form of a diagram. This is OQ, which is the vessel is already filled up to OQ with some liquid. So the central maxima is found at this point Q. So at point Q, the net path difference, that is traveled by, that is the path traveled by the light at point Q should be equal to 0. Thus, this point Q will be the central maximum. Now, we already have calculated what is the path difference of the light which is traveling from S to S1 and S2. So that is delta x1, which is 0.16 mm. Now, since after this, after the S1 and S2, the light is, one of the light waves is traveling through air and the other one is traveling through water, or oh sorry, liquid of refractive index mu. So we can find out that the path difference between these two lights, that is delta x2, will be equal to mu minus 1 into T, where T is the thickness of this liquid layer, which is equal to the width of the container, the vessel. So we can say that delta x equal to 0 implies that delta x1 should be equal to delta x2. So delta x2 is mu minus 1 into T, that is equal to 0.16 into 10 to the power minus 3. Now T is the thickness, which is given as 10 centimeters, so we can calculate mu minus 1 equal to 0.16 into 10 to the power minus 3 upon 10 centimeters, that is 10 into 10 to the power minus 2. So this comes out to be 0.0016. So mu will come out to be 1.0016.